So today we continue to learn about counting methods, and today we're learning Pigeonhole, Pascal's triangle and Pigeonhole principle. First of all, what is Pascal's triangle? We'll all learn about the Pascal's triangle. We'll dig a little bit more into the Pascal's triangle. First of all, how we build Pascal's triangle? How we can do 1, 1, 1. How we get the next number here? How we get next number here? We add these two, we put in between. So we get then 1, 1 plus 2, 3, 3, 1, 1, 4, 6, 4, 1, and so on. But what are those numbers? Where they are coming from? Those are combinations. We have this is C 0, 0. This is C. So we get C of 0 from 1 and 1, 1. Then we have C 2, 0, C 2, 1, C 2, 2. Then we get C 3, 0, C 3, 1, C 3, 2, C 3, 3. So those are, as you can see, direct relationship to number of combinations. This is number 0, 0 out of 0, 0 of 1, 1 of 1, 0 from 2, 1 from 2, 2 from 2, and so on. And from here, we can get few important conclusions. What is, how we getting, let's say, this number, C31? We get C, combination 1 out of 3. How we get this number? We add C02, 0 of 2 plus C 1 from 2. Can we write general rule? Can we see the pattern and write general rule?
Yeah.
So this will be C N R equal
N minus 1.
C N minus 1
minus 1.
R minus 1 plus C
N minus 1 R.
N minus 1 R. This is the property of the combinations. One more thing. Let's add each row. If we add numbers in each row, what we will get here?
1,
1, 2. I will use different color, so it will be more evident. We have 1, 2, 4, 8. What will be here?
12.
16. Can you see the pattern?
Yeah.
What the pattern is?
Times 2 to the power n.
2. So this is row number 0, row number 1, 2, 3, 4. So if we add all combinations in the row, we'll get 2 in the power of n. So if we add C n0 plus C n1 plus C n2 plus plus C n, it always will be equal to 2 in the power of n. What does it mean? If we have, they all will always add to 2 in the power of n. So it is how many choices we can make if we can, in total, if we can choose any number of the objects. So if we have, let's say, Joseph decided he purchased a new set of pens.
Damn.
And
to not lend from you anymore.
And he bring let's say 10 of his old pens and offered to someone to pick up any of them. So how many possible combinations it will be? If you can choose 0, you can choose 1 pen, you can choose 2 pens, you can take all 10 pens. How many possible combinations it will be? If you can choose, he bring all his 10 pens and ask that you can take as many as you want and that pens as you want.
10 factorial.
No.
You asked for how many ways you can.
How many total combinations there could be that you can take those pens? You can take none, you can take all 10. You can take 1, you can take 5, you can take none.
Oh, you mean that, okay. So 11.
Take how many pens, how many ways you can take altogether in total?
Pens, yeah.
11.
11. Why 11?
Is it 0 plus 10?
It's 1024 ways.
What?
11?
Because you have 10 pens. You can take you can take 0 pens, you can take 1 pens, and you will have 10 different ways to
Well,
do
that's
it.
cheating.
Then you can take 2 pens, and that will be C10, 2, and you add all of them, that will be 10 in the power of 10, which is 1024
That's
combinations.
cheating.
Okay, now, make sense? Another way is, where it's used in the binomial expansion. In the binomial expansion. If you want to expand, for example, a plus b in the power of 4. If you want to expand a plus b in the power of 4.
I know.
We can use this, it will be coefficient. Those will be coefficient, so we will have 1, so we have a in the power of 4 plus 4 a cubed b plus 6 a squared b squared plus 4 a b cubed plus b in the power of 4. So those gives us the Pascal's triangle.
Yeah, that's what
Pascal's triangle gives us the coefficients when we expand it binomial. Example, and it's a pity that this was removed from methods. Before it was, for example, questions like this. What will be if you have in the expansion, let's say 2x plus 3 in the power of 5? What will be the coefficient of, let's say, of x cubed? What will be the coefficient of x cubed? Can you tell me what will be the coefficient? No.
No, because you have 3 and 2, the coefficient you have to times it.
Oh, no, oh, you have to, okay.
We will have, so this will be, because to power of 3, so we will
16?
go, this 1, 5, 10, 10, 5, 1.
720.
So coefficient x5, x4, x3. So we have 10, coefficient will be 10, but we will have times 2x in the power of 3 times 3 in the power of 2.
He's right.
So that will be 10
720.
times 8x cubed and times 9. So that will be 720x cubed.
Good job.
I got that right, but so good.
720?
Yeah, I said that.
Is that? You say 10.
No, I said 10 and then I realized you have to do that and I said 720 next time.
Yeah, 7 will be 720.
Oh.
Okay,
Why
that's
is that?
Pascal strand,
I didn't
That's
say you were
6
wrong.
factorial.
So where actually is that?
which is 6 factorial, but I don't see how we can directly apply it here. Now, pigeonhole principle.
Pigeon.
Pigeonhole principle.
Yeah.
Pigeonhole principle.
I love it.
First, it says that if you have, let's say, why it's called pigeonhole, if you have n holes, and you have n plus 1 pigeon, which you need to put in n holes, there will be at least one hole which will have 2 pigeons.
Only one hole.
At least.
Only.
No.
Yeah. If you have
The-
n holes and oh, you can put.
But you might not
Oh,
put
you
the n,
know.
one of them can be
Empty.
without the empty. Yeah. This is, for example, this is called pigeonhole principle. More general principle is, if we have n holes, more general principle is, if you have n holes, and you have n times n plus 1 objects, at least some holes will have at least n plus 1 object. This is a general pigeonhole principle. We have n holes, we have that many objects, and that means at least one hole will have that many. Let's consider an example to better understand
Yeah,
the
give me an example.
application of this. Let's say at some school, after the summer holidays, teachers return to school after the summer holidays.
Wait,
And
Why is that wait?
but m has to be an integer. That's what you said before.
yeah, integer, of course. You cannot have half of it. It has to be integer. Let's say there are, let's say there are 50 teachers at school.
Not a lot of teachers.
Hmm?
Not a lot of teachers.
Let's say 50. You can take any. They come back after the summer holidays and they greet each other and they shake hands, but not necessary everyone shake hands with everyone. No, the only thing, you don't shake hands twice with someone. That's the only restriction. You don't shake hands with someone twice. You can shake hands. You can shake with some. You can shake. No, don't shake hands with anyone, or you can shake with everyone once. And looking on this whole process, chaotic process, when everyone shaking hands, the business management, economics, and politics teachers says that there are there is no teachers who shake same number of hands.
Wow.
But then, mathematics teacher always like to argue, especially with the wrong statement, says, no, it's a wrong statement. Why it's a wrong statement? Why there has to be at least 2 teachers who have the same number of handshakes?
Are you asking me a question?
Not you, everyone.
Yeah, I'm saying like this is a question.
Yeah, then I want you to think, not just me, to answer this question, why it has to be at least 2 people shake same number of hands.
Well, one person shake each other's.
No, you don't have to like shake everyone.
If you can.
So you can shake
Yeah.
hands with everyone, with all other 49 people, or you can shake with 48, you can shake with 47, you can shake with 0 people.
Yeah. Wow. So sure.
But
Oh, wait,
you
so
guys
you've
need-
got
oh.
49 other people
It's the same thing. Is it?
No,
Let's-
because when you
You
can
can
only
make-
choose between 0 to 49.
Yeah, yeah.
And then there's only one. There's going to be one other person.
Yeah.
You can only choose, you can only shake hands with 49 other people and there's 50 people, so you've got 49 options for
But you can
50
choose to
people.
not shake
so-
anyone.
Now, we have, let's say, if there is one person who shake 0 hands.
Who's Joseph?
There is one person who shake 0 hands. That means there will be, because you can shake only 49.
Yeah.
That means there will be someone who shake 48. Right?
Why?
Yeah, oh yeah, yeah. I mean,
Because you can shake people hands with the 49 people.
Mm-hmm.
One did not shake hand with you. So it's only 48 left.
Right. Yeah.
But we have 49 people. Put into 48 pigeonhole. There has to be at least one pigeonhole with the 2 people. So there will be, according to pigeonhole principle, at least 2 people.
How do you prove this? Like who? The theory. How do you prove that?
What? Now, another question. How many, do you know how many, the maximum number of the hairs the person, the human had? On the, let's say, on the head. I'll tell you, 1 million. 1 million.
I feel like it's more than 1 million.
For the purposes of this equation, so yeah.
As far as I know, it's actually 1 million. You can search later on. Now, question is, how many people lives in Australia?
27,
About 27 million. That means that there are at least 2 people with the same number of hairs in Australia. Because we have 1 million hairs, we have 27 million people. If we will try to put in the whole, there will be at least 2 people with exactly same number of hairs.
Especially all like the bald people.
Yes, that's included. Okay, that's pretty much about Pascal's strength and pigeonhole principle.
I love Pascal.
Like, subscribe, and donate to help fight terrorist countries and organizations. Support Ukraine and Israel.
Let's go!